Good morning, Dr. John. Good morning, classmate. My name is Aruna Sise. The first steam power ship was built in 1783 in France by Marquis Claude and Geoffroy. Do you know that nowadays steam is still used in most ships around the world? Today, I will be informing you about the basic steam cycle in surface ships propulsion plant. As a U.S. Navy machinist mate, I was trained to operate and maintain surface ships steam plant, which explain my choice for this topic. There are 4 phases in a basic steam cycle: generation phase, expansion phase, condensation phase, and feed phase. Keep in mind that pressures and temperatures used in this presentation are representative of specific parameters for the common 600 psi steam cycle. Actual parameters vary from specific ship's design. The following references are used in my presentation: Center of Naval Engineering Machinist Mate 3 and 2 Surface, NAVITRA 14151, Government Printing Office, March 2004. Bureau of Naval Personnel, Principle of Naval Engineering, NAV Pierce 10788 series. ConverPaste, December 26, 2009. Basil Clark, Steamboat Evolution, Lulu.com, March 1st, 2007. Firstly, generation phase is the initiation phase of the 4 phases in a basic steam cycle. According to my references, in this phase, water is boiled and transformed into steam, which takes place inside the furnace in the boiler. The boiler is a chamber where heat is introduced using fuel to bring water into its boiling temperature. As water boils, it vaporizes into steam. The boiler is pressurized to 700 psi, which means the steam formed and exiting the boiler is a 700 psi steam. Feed water enters the boiler steam drum through an internal feed pipe. The internal feed pipe allows an even distribution of feed water inside the steam drum. After the steam drum, feed water travels down the downcomers, which is located between the furnace and the air casing. As feed water travels back up into the tube surrounding the furnace, it gets heated up and vaporized into steam and rise back up into the steam drum, where all droplets and moistures are removed from the steam by the cyclone separators. The steam form continues its path to the superheater, which is located right here. So the superheater will increase the steam temperature to 850 to 950 degrees Fahrenheit. Then steam exits the boiler through piping ready to be used by the turbines. Secondly, as steam heads to the turbine, he starts his expansion phase. The turbine expands the steam, causing both his pressure and temperature to fall, engendering the turbine to rotate and perform work. In the expansion phase, thermal energy carried by the steam is transformed to a mechanical energy to make the turbine rotate to perform work. For instance, in the ship's main engine, mechanical energy is used to drive the ship propulsion shaft. In the ship service generators, mechanical energy is used to run the generator to produce electricity. In the main feed pump, mechanical energy is used to rotate the pump to send water into the boiler. Finally, after steam passes through the turbine, right here, you get exhaust into the main condenser, where the condensation phase begins. As exhaust steam loses its heat, it gets condensed into water, which is called condensate. The main condenser is a heat exchanger with several tubes containing cold water. As exhaust steam comes in contact with the cold tube, it gets condensed. The condenser operates under vacuum between 27 and 30 inches of water, which reduces the condensation temperature and make the system work efficiently. The condensate collected in the bottom of the main condenser is removed by the main condensate pump. So the main condensate pump sends the water through the air ejector, which removes air and non-condensable gases from the main condenser. Then the condensate continues its path to the feed heater and finally arrive in the deaerated feed tank, which marks the end of the feed phase. The feed phase is the last phase of the basic steam cycle. My sources indicate that the deaerated feed tank is divided into two portions. We got the upper half and the lower half. The upper half marks the end of the condensation phase, while the lower half initiates the feed phase. The deaerated feed tank has three main purposes. It deaerates feed water, which means remove oxygen from the feed water. It preheats feed water and store feed water. The deaerated feed tank also provides a positive head suction to the main feed booster pump, and the main feed booster pump provides a positive head suction to the main feed pump, and the main feed pump sends the water back up into the boiler at 850 psi. After water leaves the main feed pump, it goes through the economizer, which is located inside the boiler. The economizer is installed in the flow path of the exhaust gases exiting the boiler and use the hot gases to transfer additional heat to the feed water before he entered the steam drum. Because water is preheated through the condensation phase, throughout the condensation phase, the boiler needs to provide enough energy to rise the water temperature about 40 to 140 degrees to form steam. I know throughout my presentation, I used a lot of engineering terms. That being said, are there any questions? Well, to summarize, there are four phases in the basic steam cycle. Generation phase, where water is boiled inside the boiler to form steam. Expansion phase, where thermal energy is converted to mechanical energy to rotate the turbine to perform work. Condensation phase, where exhaust steam is condensed into water inside the main condenser. And feed phase, where condensate is preheated before going back into the boiler. Keep in mind, this is a closed loop system. The cycle repeats itself as long as the system is operating and all 4 cycles is happening at the same time. Even though steam has been used to power ships for over 100 years, nowadays diesel engines are preferred due to their simplicity. Thank you.